Welcome everybody to another series of videos. This time we will be focusing on ordinary differential equations. And we're not going to be talking about modeling and or whatnot. We're just going to be talking about the analytical solutions. And don't worry, this will be very fun. We just need to solve some equations. And now, first we're going to tackle separable differential equations. So a separable equation is the form dy over dx equals f of x of y, or maybe f of x dx plus g of y dy equals 0, or something of the sort. Basically, the important thing here is that x and y can be separated together, which means that we can move these around without much drama. So we can move this around, we can move this to the other side and whatnot, without x being interfering. So, for example, sine of x and then cosine of y. This is separable. 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 But however, some are not separable. Like sine of xy is not separable. No matter how much you try, it is not separable. Maybe you can, but that's a story for another day. So let's focus on our first problem. Now, looking at here, doesn't seem separable, right? There's like x and y contained together, but there's an x in here. What if we factor x out of it? So x then y squared plus 1. And here is where it's separable. X is a function of x, and y squared plus 1 is a function of y. They're just multiplied together, and we can move different parts of the equation into the other side. So, how are we going to solve this? One thing you have to note here is, well, this dy over dx. dy over dx is the same as y prime. And remember in implicit differentiation, you were asked to find the derivative with respect to x of arctan y. You had to do the chain rule, right? So the derivative of the outside is 1 over 1 plus y squared. And then we have to do the derivative of y. We have to put it as like y prime, or we had to put it as dy over dx. We have to multiply it by dy over dx. This is just a direct consequence of the chain rule. This is also going to be a direct consequence of the chain rule. So let's try dividing both sides by y squared plus 1. We get 1 over y squared plus 1 dy over dx equals x. So now on one side we have y exclusively, on the other side we have x exclusively. We have separated them together. So now all we have to do is to integrate them with respect to x. All right. So here we have an integral with respect to x, but there's dy over dx here. Now, what does this all mean? Can we uh can we cancel this out since it's a fraction? No. Dy over dx is not a fraction, it is only a notation. Dy over dx means the derivative of y with respect to x. It doesn't mean dy divided by dx. In some contexts, yes, it means that, but not here, not in pure mathematics. Maybe if you're in engineering or IT or whatever, and you're learning calculus there, they will ask you to cancel this out. But they're not really canceled out. It's just a shortcut. This is actually integration by substitution. So basically saying let y be equal to u. What's the derivative of y? That's going to be dy over dx. And then you put dx here, and then this is equals to u. So basically, what this happens is du over u squared plus 1, and integrate that. We get arctan of u, correct? And then since u equals y, it's just arctan of y. That's essentially what's happening uh, when you integrate this form. In shorter words, dy over dx gives us a sort of permission to integrate with respect to y. So we're asking x if we can integrate y. So we can integrate by y. So let's not put equals there. Uh, the integral of this with respect to y is arctan of y. Now it's a different story if it's with respect to x, but we're asking x if we can integrate with respect to y and whatnot. We can put c1 here. Let's just put c1. Then equals x squared over 2 plus c2. Now, some will just ignore this c1 because we can subtract c1 here. And what happens when you subtract a constant from another constant? You get a constant. So we can just ignore this and then just put a constant right here, which is what most people do anyway. So we have arctan y equals x squared over 2 plus c. Is that finished? Well, yes, this is the solution. But maybe we can simplify it further. If we take the tangent of both sides, let's move the equal sign here. If we take the tangent of both sides, the tangent and the arctangent cancel each other out because it's function in an inverse. So y is then equal to tangent of x squared over 2 plus c. That is your answer. This is the general solution. There's a lot of other solutions which can vary because of the constant c. It's an arbitrary constant. Basically, what it means is this doesn't need to be like 0 or 1 or 2. It could be any constant you want, as long as it's a constant. And that constant will make the graph vary or the function vary with each other if you look at it in a graph. So there's no specific here, so we can move to the next question. dy over dx minus e to the x plus y equals e to the y sine of x. Now, what we can do first is to move it to the other side. So dy over dx is then equals e to the x, also e to the y. Let's put the here, this first. Then plus e to the x plus y. The loss of exponent states that we can say this is e to the x, e to the y. All right. Now, since they both have e to the y here, we can factorize them out. So we get e to the y sine of x plus 1. Sorry, e to the x here. Alright. This is dy over dx. Now look here, we have a function of y and we have a function of x, which is what we need in order to make it separable. So now we can put e to the y on the other side. This becomes e to the negative y dy over dx equals e to the x plus sine x. Yeah. So now what we can do here is to integrate both sides with respect to x. Now, if you don't want to go through the headache of doing whatever is needed here, you can just cancel it out. But just know that it's not really canceling the x out. It's just asking permission. So the integral of e to the negative y with respect to y is going to be, let's move the equal sign, negative e to the negative y, and the other side is going to be e to the x minus cosine x. Then we have plus c here, and I'm not too sure that c is the final form of that. So let's put c1 in here to indicate that c, the constant, the arbitrary constant, is still going to change as it goes on. Solution. Now, we can stop here, or we can isolate y. So how can we do that? First, let's multiply by negative 1. So we get e to the negative y equals negative e to the x plus cosine x plus, and a negative of a constant is still a constant, but it's another constant. So we call it C2. And then we take the natural logarithm of both sides. We get But natural logarithm and e to the negative y cancel each other out since it is a function in an inverse. And then we take the ln of the side, negative e to the x plus cosine plus plus c2. Now c doesn't change here since we're taking the natural logarithm of the entire function. So c2 will remain as c2. I forgot about the y here. Yeah, there. Let me rearrange that. Negative y is equals to this. The final step is to just multiply it by negative 1. Now, since C2 is pretty unchanging here, let's just put it as C, the final C. Now, we have the condition y of 0 equals 2. This means that if x equals 0, y equals 2. So let's substitute it into the function. So 2 equals negative ln of negative e to the 0 plus cosine of 0 plus c. Negative e to the 0 is negative 1 plus cosine of 0 is 1. Then c is just c. We don't know what it is yet. And then the negative here, actually, we can put that to the other side. So it would be easier to isolate c. Now, negative 1 plus 1 is 0. So ln of c equals negative 2. We raise e to both sides. We get that c equals e to the negative 2 or 1 over e squared if you're nasty. Alright, so reverting back to the original equation, y is equals to negative ln of negative absolute value of negative e to the x plus cosine x plus 1 over e squared. There you go. This is the uh, specific equation because there's no more arbitrary constants. We've resolved that because of y of 0 equals 2. Yes. And one more, a bonus round. All right. Y squared multiplied by x squared plus 1 dy plus 1 over 1 plus y squared dx equals 0. Now, what's going here is that there's dy here and there's dx here. Whatever whatever their variable is, we need to move everything to there. All right. So for example, this we need to move it somehow here, and this we need to move it somehow here. How do we do that? We multiply both sides by its reciprocal, or we just divide both sides by this one. So we get y squared over 1 plus y squared dy plus dx over x squared plus 1. You can check that by yourself, but that is how it's how the results are when you divide it by that. So next step is to just put integral signs everywhere. Honestly, we just integrate the entire thing. Now, I said a lot of things while like differentiating dy dx. You need like dy over dx here and whatnot. This is a close approximation to that because this is actually dy over dx, and then this dx is dx over dx, which is 1. But for the purposes of this, we are allowed to do this. Just integrate and then dy. Then and the integrate 0 will make sense later. So what now? Let's solve the easiest one here. This. The integral of 0 is just a constant because the derivative of a constant is 0. So this one is also easy. This is just arctan of x. This one is a bit difficult. So let's try a few methods. You can use division here. So 1 plus y squared and y squared here. Then you can use blah, blah, blah division. But I'm not a fan of that. I'm a fan of this. What if we add 1 plus here? 1 plus 1 plus squared. It would be nice, isn't it? Because this is just 1. You can just divide that and it's done. But that's different from what we have. So we need to subtract by 1 in order to cancel out the 1 that we added. It's plus 1 minus 1. So you give and then you take. So this one, we know this is just 1. We can just cancel that out. And then this becomes 1 over 1 plus y squared. And the integral of that with respect to y, well, the integral of 1 is just y. The integral of 1 over 1 plus y squared is just arctangent of y. Then we just add plus. And this is the general solution. We still need a specific solution. So we have x equals 1 and y equals 1. So let's put everything together. All right. So we have substituted x equals 1 and y equals 1. Arctan of 1 is pi over 4. You can check that on your calculator if you have one. So this is going to be negative pi over 4, and then 1 remains as 1. This and that cancel. So we remain with c equals 1. That's going to be the constant for this one. So let's put it together. Y minus arctangent of y plus arctangent of x equals 1. And that is the specific specific equation for this one. I'll be back with more of this in the next video. Bye bye.